Okay, so we just saw how data and platform depth create a moat. But that personalized utility is, well, it's worthless without the hardware to process it quickly and at scale. And that brings us to the compute layer, because the pressure on the supply chain and latency is leading to a $10 billion investment in Revolt.
The premise here is pretty simple. For 2 years now, AI capability has been shackled by the Nvidia bottleneck. The availability of specialized compute, primarily high-end GPUs, has basically determined who gets to train the next frontier model.
Right. It's been a kingmaker.
It has. And the news today shows that the biggest players are taking radical steps to diversify away from this single point of failure. And this push for hardware independence is happening simultaneously on two critical geopolitical fronts.
Let's start in the West, because the number is just.
Yeah.
It's astonishing. OpenAI's $10 billion multi-year deal with Cerebras. This is not a small R&D project. This is a declaration of war on the status quo.
It is a decisive and very high-stakes move. OpenAI has signed a contract worth over $10 billion with Cerebras. That's the AI chipmaker famous for its wafer-scale engine technology chips built across an entire silicon wafer, not just a small square die.
Right, the giant chip.
The giant chip. And this massive contract commits Cerebras to providing a stunning 750 megawatts of dedicated compute power through 2028.
750 megawatts. I mean, to put that in perspective for people, that's equivalent to the electricity consumption of a city the size of Omaha, Nebraska, purely dedicated to running OpenAI's workloads. So what's the why behind this colossal investment, and why specifically target a challenger architecture like Cerebras instead of just, trying to secure more standard Nvidia supply?
The strategic goal is twofold, and it speaks directly to the constraints they're facing. First, they need massive, dedicated scale away from the primary bottleneck. They're diversifying their supply chain risk. Second, and maybe more importantly for their customers, the purpose is achieving faster outputs through a dedicated low-latency inference solution.
Okay, let's focus on that low-latency inference, because that's the customer experience layer. Inference is the process of using the trained model to generate responses. And latency, the time it takes, that's the killer of perceived AI performance, especially for complex multi-step queries.
Exactly. And Cerebras' unique architecture is specifically suited to tackling this latency problem. See, a standard GPU cluster requires data to be broken up and communicated constantly between different chips across a high-speed network, like InfiniBand. That inter-chip communication introduces bottlenecks and latency. The Cerebras wafer-scale engine is essentially one gigantic processor with massive on-chip memory. It keeps the entire model and its computations localized on a single giant piece of silicon.
So by minimizing that external communication, they minimize the wait time. OpenAI is validating Cerebras' core claim with a $10 billion check. They're saying that specialized wafer-scale chips are inherently faster and more efficient for specific high-demand inference workloads than general-purpose GPU systems.
It's a fundamental strategic move to secure scale and diversify risk. However, let's introduce a note of skepticism here for our investors. This $10 billion contract is crucial validation, yes, but Cerebras is a company that has delayed its 2024 IPO, while reportedly seeking to raise another $1 billion at a very high $22 billion valuation.
That sounds like a significant operational risk.
Yeah.
I mean, betting such a massive sum on a company that hasn't proven its financial stability on the public markets yet, isn't this also a sign of just desperation for compute access?
I think it shows that the need for supply diversification outweighs the financial risk associated with the partner. The cost of not securing compute scale is far higher than the risk of Cerebras' valuation wobble. This investment signals that access to compute capacity, especially capacity optimized for low latency inference, is the single most valuable asset for a model provider today.
Okay, so that's the West's move to secure specialized scale and lower latency. Now let's turn to the East, because China's response to the chip war is not reactive. It's about proactively building parallel self-sufficient infrastructure.
Precisely. We're seeing hardware independence being driven by geopolitical necessity and U.S. export controls. The Chinese startup Zhipu AI, which has already impressed globally with its large language model, GLM 4.7, just made a powerful statement. They released GLM-Image, a new 16 billion parameter open source image generator.
And the crucial detail here, the thing that makes this a geopolitical signal, is what?
This model was trained entirely on Huawei's Ascend chips and software stack. With zero reliance on U.S. semiconductors or architecture, this is the first major capable open model trained fully within a self-sufficient domestic Chinese hardware stack. It's not just a technological release, it's a proof of concept for national resilience.
That's a monumental achievement,
Yeah.
just in terms of establishing a parallel supply chain, even if the performance isn't market-leading yet. And speaking of performance, Zhipu is claiming some impressive metrics, particularly for niche use cases.
They are. They're claiming GLM-Image excels particularly at text-heavy images, which is something image generators often struggle with. And they say it beats a competitor like Nano Banana Pro on specific internal accuracy benchmarks. However, early user reality suggests that while it's highly capable, it still trails the very top closed options like Nano Banana Pro and Dream on overall photorealistic quality and creative coherence.
But if we connect this to the bigger picture, that performance gap, while it's relevant for consumer metrics, it isn't the primary strategic driver here. The main story is the geopolitical signal. Zhipu's aggressive moves, releasing this domestic hardware-trained model right after their powerful GLM 4.7 and their recent Hong Kong IPO, it proves that China's AI industry is not waiting for export controls to relax. They are building a self-contained AI ecosystem from the silicon up, ensuring their national security and technological future are not dependent on external vendors.
And the implication for developers is clear. The market is fracturing. Hardware is becoming specialized, not standardized. You can no longer rely on optimizing solely for Nvidia's stack.
Right.
To address the massive Chinese market or specialized enterprise needs globally, you will increasingly need to optimize models for different architectures. We're talking standard GPUs, Cerebras wafer-scale engines, and Huawei's Ascend stack. This complexity introduces significant friction.
And for investors.
The era of the single hardware king is, I think, indeed approaching its end. Compute supply chain fracturing creates both risk and opportunity. The risk is high operational friction and potential lock-in. The opportunity is in investing in the enabling software layers, the compilers, the optimization tools, the middleware that make cross-architecture deployment and performance tuning easier. The money is flowing to alternative chip producers and the software that ties them all together.